Hello there, everyone. This is Vidya, and I've been a software engineer for 4 years, and now I've realized the importance of DSA if you have to crack a big tech company, right? So that's when I started learning about the basics and the different types of data structures that are available, and basically you should have a thought process on how to handle or how to store your data so that the retrieval of this information becomes easier, right? So the very basic concept that you would come across when you start DSA is your two sum. Of course, it falls under the array concepts, and array is like the very basic thing in DSA, I would say. So let's get started. And while I'm here on this journey, I'll try to explain the process, the thought process, and the intuition that I have, and just hope that you guys are getting some help from me in the very same process, right? So let's get started with the video. And the very first question that we have today is your two sum, right? So given an array of integer nums, an integer target returns indices of the two numbers such that they add up to a given target. So you may assume that each input is would be having exactly one solution, and you may not use same element twice. All right, okay. So wouldn't this be actually okay? I mean, you can't use the very same number at the very same index, right? So you can't add 3 plus 3 over here and make it. Basically, you should have two different indices in order to perform an addition. So now if you consider, so my inputs is equal to nums. This is gonna get injected over here, and my target is also gonna get injected here. So now the explanation of this would be, in this given array, if I try to add 2 plus 7, I'm gonna get my 9. So 2 is at index 0, 7 is at index 1. So I want to return 0, 1. So what would be the, let's basically start with our brute force approach, which will provide us a baseline, and post that we can try to optimize the solution. In the brute force approach, what would I do? I would have two pointers, right? Let's get started with that. So I want my I to be at index 0, and then this should be lesser than nums dot length. So basically this length function is always kind of confusing me for some reason. The reason being is very simple, right? If it's an array, you have to use it dot length, but if it's a string, you have to do use that as a method, basically length and the brackets, right? So that is one trick that I use to so that I don't get confused while writing my logic. Okay, so I want my I to iterate from 0 to n. So how would my j iterate, right? My j would iterate from here to here. So let's get started with the j wala iteration loop. And now I would say int is equal to 1. I would say, in fact, I would say it as I plus 1, because in the very first iteration I want to start it here, but when my I is here, I wanted to run through this, right? So this is how my condition is going to be set at, but again I wanted to traverse through the entire array. This I would be configuring it as, again j should be of course lesser than equivalent to length. So this is my condition, right? So this part is clear. Now the condition that I would write is, the element that I'm trying to access at the jth position plus the addition of the number that is at ith position, if is it equal to target. As in, I'm putting a condition here stating that if my nums of j plus nums of I is equivalent to target. Target, of course, you are getting it from the method level, right? Method level parameterized constructor that we have over here. So Now this part is clear. If my this condition turns out to be true, then I'm just have to return how do you return a new int array? I can do it this way around, right? So the indices, I have to return the indices, right? The position of these. So how can I do that? I can just do I comma j. Simple. And once I'm out of this loop, say suppose if there isn't a condition, then I want to return maybe -1, right? If the combination is not occurring, the base condition though has to get returned. And this is after both the for loops that I would be returning. And I would either return, I would just return the base condition is basically not given. So your not target would be this, and your nums length will always be lesser than this. All right. Okay. Mm, always when you're stuck in any questions, you can always make sure to go through the hints. But before that, let me try to return an array with -1 as an index, I guess. So let's try to run this. It's a brute force approach, right? For int j is equal to I plus 1. And what is wrong over here? Okay, the length spelling is wrong. ठीक है, fine. Let's try again with this. All my test cases are getting passed, but let's try to also go ahead and okay, fine. So this solution got accepted, right? This is the brute force approach, and the solution did get accepted. But if you see it is somewhere over here, it is not that very impressive, right? There are so many people above uh, you who have given a solution that would beat this runtime. So this is of course a brief, and since there are two nested for loops, I would say the time complexity for this approach would be O of n square. This would be O of n square. So if you actually try to, of course, we learned the given question, we went through the examples and tried to see how we can arrive at a solution. But there is a follow up over here asking, can you come up with an algorithm that is less than? Okay, we came up with a brute force, of course. Now, how do I reduce the complexity over here, right? So, what if I actually track if the a better approach of this I would consider is a hash map, right? Using an hash map. So, say suppose, so in my OneNote, if I'm trying to show you, say suppose I will try to use a, I can't use a set. I need to track the number and I need to track its index also. So the thought process would be I will try to save the number value. So of course I need to come up with a map, and map would be of type integer, comma, comma integer. It's a map, it's a key value pair always. So now I'm gonna in this very first, that is a key, I'm gonna store my value, and in the other value I'm gonna store my index where it occurred. So if I tell 0, now I'm trying to see if target, if this number already there in the queue, I mean no it is not, then I go ahead and add it. And in the next step I'm trying to see if my complement, as in say suppose there is a 9 minus 2 would be giving me 9 minus 7 would be giving me 2, right? 9 minus 2 would be giving me 2, but already this 2 is already there. So what I can do is I can just return this index, and along with that the iteration of loop, that is O of n. Let's try to implement it, okay? And I'll try to see if that would make sense. So of course I would still start from I is equal to 0, but let's get rid of this middle element that we have. All right, okay. there is one thing that is missing. So if I try to see here, right, inside my for loop, I want to iterate through all the way. But before that, let's create an hash map. And how do you create a map? Map of integer, comma, integer, right? Let me call it as map itself, and it would be a new implementation of hash map. यहाँ पे you don't have to mention the type of data type as in such, right? Here if you mention it as an integer, that is more than enough. So now what I would do is, I'm always validating if my map dot contains complement. What is complement? It is nothing but target minus nums of I, right? Nums of I keeps changing, so you don't have to initiate a variable over there to keep a track of it. You can directly put this over here. So in the first loop, what happens? My map is empty, it doesn't contain anything. So target minus 2, that is 7, which is already not there. In that condition, I go ahead and add nums dot I into my map. So how do I do it in map dot put? So I will try to do this. Of course I want my nums of I, comma I, right? I want to track my index also, so this would be 1. So let me go on to, what if it is not there? Fine, what if it is there? If it is there, if map doesn't contain, you go ahead and put it. But what if it is not there? Else, in the else condition, what you can write is, can I write it as, if it is present, then I'll have to return new int array with index. Of course, first thing is my j is already available, right? My I is already available. I can just iterate and give it back. And now I'll have to find what is the corresponding value for this, right? How can I do that? Map dot get of nums I. So if I'm passing the key over here, how is it actually stored in the hash map? It is stored in this format, right? 2 comma 0, right? So if I want to retrieve this index, I'll have to do a map dot get key. Map dot get key is here. Key is nothing but 2. Is it number of 2? No, it should be target of I minus 1. If this number already exists, then provide this into I, right? So in this process, I would be doing my due diligence over here. So let's try to run this and see if this works. If map dot contains, okay, since it's a map, we have to specify it as whether it is containing the key or containing the value. So I'll just do contains key. Let's try to do this, if this works. Of course, right? So now we have all 3 test cases. Now let's try to submit it. You see, we were at somewhere around beating 17% to beating 61.68% now, which is great, which is a great solution, I would say. And is there any other approach at all that can actually make this go to better state? So let's try to see what is the other solution. I mean, this is a very same fucking solution that I provided, but okay, let's try to. It is more or less the same, right? I just want to. Okay, I'm gonna return a new int array. I is equal to 0 and map dot get client element. So that would be, or else. I just hadn't put a else loop, right? the previous approach, I'm just gonna remove. Okay, but either ways, which is good, great. So this is the best approach. And along with this approach, what is the time complexity that we have come down to? I would say space complexity, that is the memory that we have been using. We are just defining a hash map, and of course there isn't gonna be any much of space redundancy anywhere. So in that case, I would say it's O of 1. And given the consideration, we just have a for loop to iterate against. We're just iterating each by each just once. So from O of n square, we have reduced the time complexity to O of n. So that's about this question, and I have learned this the hard way. So, but that being said, if there is any other better approach that you have in your mind, kindly do let me know in the comment section, and of course, I'll try to reiterate through that. And so, yeah, that's all I have for you guys today.